Hey guys, it's Mr. Blazik. I miss you guys all a lot. I hope you guys are doing well and staying safe during these times. I figured I'd make another video this time going back to something that we learned all the way at the start of the year. We learned this actually in August, and this is unit rates. So starting off with unit rates, we're going to define two different terms today. We're going to define ratio and unit rate. And so the first term, ratio, is just simply a comparison of two different things. And so you can think of that as like the comparison of the number of boys in our class, compare that to the number of girls in our class. And that would give you a ratio. Now, we're mostly going to be focusing today on unit rate. And our definition for unit rate is very simply the amount that 1 unit of something costs. So if you were buying a packet of 100 items, and that costed you $138, and you wanted to figure out the amount that one item would cost you out of that pack, that would be your unit rate. Now, we're going to look at a real life example today of something that you could experience by going to the store right now. We're going to look at buying some packs of toilet paper. And so in our example, we have two different options of toilet paper that we could buy. Our first option here, this is a 6-pack of toilet paper. And this 6-pack of toilet paper costs us $7.25. The other option that we could buy is we could buy a single roll for $1.25, and we could buy 6 of those rolls instead. And so the question that we want to figure out is which one of these two options is going to save us the most amount of money. Now, there's different ways that we could approach this problem. Today we're focusing on unit rate, and so we're going to figure out the amount that a single roll of toilet paper is going to cost from this pack. Because if we know what one roll here costs, if it's more expensive than this roll, then this whole pack is going to be more expensive. On the other hand, if this one roll is cheaper than this $1.25 roll, then that means this whole pack will be cheaper. So we want to figure out how much one roll is going to cost from this. Okay, so to do that, we have our 6 rolls per pack, and that costs us $7.25. To figure out what one roll is going to cost us, we're going to do something that all of you guys hate doing. We're going to do some division. We're going to divide the total cost that we're paying, in this case $7.25, divided by the number that we have in our quantity, which in this case is 6. So 7.25 divided by 6. And we're going to do some long division here. Starting off, we have 6 goes into 7 one time. 6 times 1 is 6. 7 minus 6 is 1. Bring down your 2 would give us 12. 6 goes into 12 2 times. 6 times 2 is 12. I'm going to run out of room here. Bring down my 5. 6 goes into 5 0 times. That would give me, I'm running out of room here. I'm just going to kind of rewrite it over here. 0. Bring down. You're just going to have to believe me a bit here that this is all correct. 6 would go into 58 times. And my decimal here would give me 8.208, which we're going to round to 1.21. So going back to this problem, this means that this one roll is going to cost us $1.21. One of these rolls is $1.21. In other words, this is going to be cheaper. We're going to save money by buying this. Now, if you don't believe me, there's another way that we can look at this as well. We could figure out what would it actually cost us if we purchased 6 of these. Right? Because that's what we're saying is we want to figure out, is this cheaper than buying 6 of these? And so we can just do the multiplication of 1.25 times 6 of these. And we'll see what that costs us. So 1.25 times 6. 6 times 5 is going to give me 30. 6 times 2 is 12. Plus 3 is 15. 6 times 1 is 6. Plus 1 is 7. My decimal goes over 2 places, so we get 7 point, let me get my decimal in there, 7.50. So when we buy 6 of these, 6 of these green toilet papers, that would cost us $7.50. And so for the same amount of toilet paper, we'd be paying 25 cents more by buying the singles, which tells us that is not a very good value. We'd get more value by buying the 6-pack. And thankfully, thanks to our teacher who we listened to in 7th grade, we can now buy toilet paper and save 25 cents. Congratulations, you are now able to survive the pandemic thanks to 7th grade math. Okay, we're going to work through one of the questions that I have posted for you guys on your quizzes. I'm sorry to Brittany, who already did the quizzes and doesn't get the free question here. To the rest of you, it'd be very embarrassing if you get this question wrong on your quizzes after you watch this video. Okay, our question is, Mr. Hart made his students run 5,280 feet, 1 mile, for their physical fitness test. If Jasmine finished her test in 5 minutes, how many feet did Jasmine run per minute? So we want to figure out, because she ran 5,280 feet in 5 minutes. That's exactly how far she ran in 5 minutes. And we want to figure out how far she ran per 1 minute. So to figure that out, again, we're going to do everything that you guys hate doing. We're going to divide. We're going to divide 5,280 divided by 5. And that's going to tell us how many feet she ran per 1 minute. So 5 divided by 5 is 1. 5 times 1 is 5. Subtract that. Again, I'm going to run out of room. Gosh darn it. You know what? Give me 1 sec. Okay, we're going to do it up here. 5 divided by 5 is 1. 5 times 1 is 5. 5 minus 5 is 0. Bring down my 2. 5 goes into 2 0 times. 5 times 0 is 0. Bring down my 8. 5 goes into 28 5 times. 5 times 5 is 25. 28 minus 25 is 3. Bring down my 0. 5 goes into 30 6 times. 5 times 6 is 30. Which gives us Jasmine ran 1,056 feet per minute. 1,056 feet per 1 minute. Very nice job, Jasmine. That's a lot faster than I could run. So she ran 1,056 feet per 1 minute. So if you were doing this quizzes, you would pick option 3. And please don't get this wrong after you've watched this video. I'd be very, very sad. Okay, the other thing that I wanted to cover in this video is the constant of proportionality, which is the other thing that we learned when going over unit rate. And the constant of proportionality is a very, very simple definition. It's just a constant value of something. And we're going to see two examples here in our tables here that explains what that constant value looks like. So we have two tables here. Well, we have three tables, excuse me, with an X and a Y in each of our tables. And if we look at the ratio in this table here, the ratio in my first row here is 10 to 1, which means that rate is 10. Okay. This ratio here is 20 to 2, which would give me a rate of 10. This here would be 30 to 3, which would also give me a rate of 10. 40 to 4 would give me a rate of, class, you know it, 10. 50 to 5 would give me a rate of 10 as well. And so because each one of these has a constant or has the exact same ratio, that makes this the constant of proportionality. And so we would write that as K is equal to 10. So this set of information has a constant value throughout each one of these rows. Similarly over here, if we look at each one of these ratios, this one here would be a ratio of 4 to 1, which would give me a rate of 4. 8 to 2 would give me a unit rate, again, of 4. 12 to 3 would give me a rate of, you guessed it, 4. 16 to 4 would give me a rate of 4. And 20 to 5 would give me a rate of 4. So over here, each one of these has the exact same ratio. Each one of these ratios is 4. And so we would say this table has a constant of proportionality of 4. Now, our last table here is going to be an example where we don't have a constant of proportionality. And so if we figure out our ratios here, this first one is 5 to 1, which would give me a rate of 5. My second row now would have a ratio of 5, 5 to 2, which would give me a rate of 2.5. And so right away, I have two different ratios here. And because I have two different ratios within a given set of information, I am not going to have a constant of proportionality. Right away, this tells me that my constant of proportionality is going to be 0. And we write a 0 and we cross it out. I don't know why. You have plenty of free time right now, so you can look it up yourself and let me know yourself why. So in this set of information, my constant is equal to 0. And if we continued with this information, we would have a bunch of values that are all different. Even if we had a bunch that were the same as this one, so if the rest of these was for some reason 2.5, as soon as we had any that were different, then my K is 0. So I don't need to continue as soon as I get two values that are different. As long as they're all still the same, though, we do need to keep checking until we get to the last one. Because you could have a situation where you had the first 4 rows all had the same value, and then your 5th row was different. And as long as one row is different, then your constant is 0. As long as every row is the same, then your constant is whatever that unit rate is. Okay, just to show you what two graphs would look like with constant of proportionalities, I haven't actually written in the numbers. But regardless, when we have a constant, it's always going to be a straight line. And you can kind of pretend that's actually a straight line. It's hard to draw a straight line. It's a perfectly straight line, and it should pass through your center of your graph right here. So if there's ever a constant, it should always look like that. It's going to be some type of straight line. Okay? Now, over here, if your constant is ever 0, your graph is going to look a little bit different. We can notice it's not a straight line. It's because we don't have a constant. And it could be curved in lots of different ways. It could be zigzagged like this. Regardless, all we know is it's not going to be perfectly straight like it would be if there was some type of constant of proportionality. So if k was ever equal to anything other than 0, then we would have a straight line. But as long as it's equal to 0, we do not have a straight line. Okay, the last thing that we're going to do together today is we're going to take a look at one of the questions on the quizzes going over constant of proportionality. So the question here is, what is the constant of proportionality for the chart above? And so the first thing we need to ask ourselves is this actually going to have a constant of proportionality? And we can see here, this is going to be, if we connect our dots here, let me try that a little bit better. If we try a little bit better to connect our dots, we can see that it is going to be a straight line, and it is going to pass through our center here, which means this does have a constant of proportionality. Right away, that does let us eliminate option 1, because option 1 is telling us that there isn't a constant of proportionality. And if there isn't a constant of proportionality, it wouldn't have a straight line. So now the question is, what is the constant? Is it 1, 2, or 3? To figure that out, we're going to write down this information in a graph, or excuse me, not a graph, in a chart. With an X and a Y side. We're going to skip our origin here, this point here, because we don't need that value here. It's going to actually throw off our information. That's just showing us that it's going through the center here. We're going to start here with our first point, which our X is at 2. And for our Y, that's our vertical number here. It goes up to 1. This next one here, X goes to 4. And it goes up for our Y 2. Our third one here, our X is 6. And our Y is 3. And our last point that we're going to look at is 8 for my X and is 4 for my Y. So if we were to divide each one of these to figure out my rate, so 2 divided by 1 would give me 2. 4 to 2 would give me a rate of 2. And you can see a theme here. 6 to 3 would be this rate, which would give me a unit rate of 2. And 8 to 4 would give me a unit rate of 2. So all of these have the exact same rate. They all have a rate of 2, which means my constant of proportionality is 2. And so we would, we would circle, or not circle, but select the yellow one. K is equal to 2. That's going to do it for this video. I hope this was helpful for you guys. Hopefully you guys remembered some of this. If you didn't remember any of it, hopefully you learned something new. I really do miss you guys. It's been really weird working from home. I hope you guys are doing all right at your guys' houses. I hope you're still learning something. I'm sure you're having, I don't know, I hope you are having fun. I hope you are being safe. If you need anything, if you need help with anything, feel free to reach out to me in Google Classroom or with my email. And I guess since officially I am a YouTuber now, I need to finish this video by saying make sure you like, comment, subscribe, share, smash that like button. Bye, guys. I'm Sue.